Hello everyone, I'm Mr. Furlong, and today we're talking about subatomic particles. In the last video, we ended with talking about the three subatomic particles. Those were the protons, neutrons, and electrons that make up an atom. In this video, we're going to look at each of those different types of particles. Subatomic particles are very small, and their masses are very small. So when we go to look at the mass of these particles, we're going to use a special unit of mass known as the atomic mass unit, or AMU for short. We can find all of these on the periodic table. And let's take a look at number 5, boron, right? Because science is anything but boron. Anyways, we see that there are two numbers here. We see the number 5 and the number 10.811. The number 5 is the atomic number, which tells us how many protons there are in the nucleus of an atom. It also, because these atoms are electrically neutral, will also tell us how many electrons there are. The number 10.8, I'm just rounding that, is the atomic mass. So that is the total number of protons and neutrons. So knowing these two numbers, we can figure out a few things about these atoms. So let's just make sure we have this down. That a proton has a mass of 1 AMU, a neutron has a mass of 1 AMU, and an electron has a mass of 0.005 AMUs. These are very small, to the point where we're not even going to consider them as part of the mass of an atom because it is so small. When we look at the atomic mass, we know that it is an average mass of an atom. So for instance, boron was 10.8. Well, if it really tells us how many protons and neutrons there are, how can we get 0.8? So when we're using some of these numbers, oftentimes we're going to round them to the nearest whole number. The other number that we saw was the atomic number, and that is how many protons are in the nucleus of the atom. Knowing those two numbers, the atomic mass and the atomic number, we can find out how many protons, neutrons, and electrons are in an atom. For example, the atomic mass of nitrogen is 14. Now I'm just simply rounding this. It's actually 14.006. For our purposes, we just want to round all these to the nearest whole number. The atomic number of nitrogen is 7, which means that nitrogen has 7 protons. It has 7 electrons because those two numbers have to be equal, and they're always going to be equal to the atomic number. But how many neutrons does it have? Well, we have to do a little math. We know that the atomic mass is 14. From that, we have to subtract the atomic number, which is 7, and that gives us 7. So that tells us that we have 7 neutrons as well as 7 protons and 7 electrons in nitrogen. Now all these numbers were 7, but does it always work out that way? Well, let's take a look at aluminum. The atomic mass of aluminum is 26.98, so we're just going to round that to 27. The atomic number is 13. Remember, the atomic number tells us how many protons we have, 13, and how many electrons we have, 13. But does it really have 13 neutrons? Well, we have to do a little math again. Take the atomic mass, 27, minus the atomic number, 13, and if we do our math properly, we get, in this case, 14 neutrons. So a typical atom of aluminum has 13 protons, 14 neutrons in the nucleus, and 13 electrons. And of course 13 and 14 in the nucleus adds up to 27, which is the atomic mass. So again, we have to note the number of protons, neutrons, and electrons are not always going to be the same. And in fact, even if we calculate this like we just did with aluminum, we might not always get the same number. And that's because there are different types of nitrogen atoms. There's different types of aluminum atoms in nature. If they don't have the same atomic mass, then we can say that it is an isotope. So an isotope is an element with the same atomic number, but they have a different atomic mass. So an example of this might be carbon. Some types of carbon have an atomic mass of 12, which means that they have 6 protons and 6 neutrons. But some types have an atomic mass of 14, which means that they always will have 6 protons, but they have 8 neutrons. And so that changes the mass. Both of these are carbon, whether it's carbon 12 or carbon 14, but they're isotopes of one another. And you may have heard of carbon 14. This is the element that they use in carbon dating. Because we have isotopes, this is why the atomic mass is really the average atomic mass. Well, what does all this mean about average atomic mass? Let's take a look at boron. There's 2 different types of boron atoms. There's boron 11 and boron 10. Boron 11 is the one that we see on the periodic table. It has 5 protons, 5 electrons, and because the atomic mass is 11, 11 minus 5 is 6, it has 6 neutrons. But some types of boron atoms, although they still have 5 protons because it's the proton that tells us what the element is, and 5 electrons, because it has an atomic mass of 10, 10 minus 5 is 5. It's still boron, but it has a different mass, and so these two are isotopes of one another. But in nature, 4 out of every 5 atoms of boron is boron 11, and 1 out of every 5 atoms is boron 10. And so scientists just say, well, 4 out of 5 is 11, a fifth of them are 10. If we average that out, we get 10.8, and that's what we put on the periodic table then. What I would like you to do next is to fill out the table on the next page in your notes. And we're going to do a few of these together to show you how this is done. We want to find the symbol, the atomic mass, atomic number, number of protons, electrons, and neutrons for these elements. Now, let's start with hydrogen. That's a simple one. The element is H. The atomic mass, we're just going to round that, is 1. The atomic number is 1. So we know automatically that it has 1 proton and 1 electron. These numbers here will always be the same number. Right? Protons, electrons are always equal to the atomic number. Number of neutrons is where we have to do the math, and so we simply subtract the mass minus the number. 1 minus 1 is 0. Let's take a look at helium. Helium is He. It has an atomic mass rounded to 4. The atomic number is 2. So it has 2 protons, 2 electrons. Those numbers are always the same. How many neutrons? 4 minus 2 is 2. Let's take a look at beryllium. Beryllium is Be. It has an atomic mass of 9. Its atomic number is 4. So we know that it has 4 protons and 4 electrons. 9 minus 4 is 5 neutrons. Carbon is C, has an atomic mass of 12, atomic number of 6. So again, we know that it has 6 protons and 6 electrons. 12 minus 6 is 6 neutrons. Go ahead and practice doing this using your periodic table. Find the atomic mass, find the atomic number, and complete this table. And we'll go over these answers in class.